Hi, Ms. Samir here with some problems from the quiz. This was the quiz that's due tomorrow. So if you happen to see this video before then, you'll know how to go back and work on some of these. If not, you will have an opportunity when you do the test to get some of these correct. So these were selected problems that were requested. All right, so the first problem requested was number 4. And it says, what is supplementary to angle G? Well, keep in mind, when you have a quadrilateral inscribed in a circle, we now have inscribed angles, okay? And because of the inscribed angle theorems, it leads us now to opposite angles being supplementary in a quadrilateral inscribed in a circle. So if G is our target angle here, then I would be its supplement. So that would be, the answer would be a supplementary. So if G happened to be, let's say 100 degrees here, then I would be 80. All right, the next problem that was requested was number 13. Number 13, for that question, this setup, we have a few things happening here. One, angle A is half of 50, because if we follow this arc all the way back in, that's an inscribed angle, so that's 25 degrees. If we follow C all the way back in or follow C all the way out to this arc, we get 41. Some of you are probably wondering, what about angle B? Well, this is half of a circle. And if this is half of a circle, it's 180 degrees over here. That 180 degrees goes all the way from here and extends all the way to there. So if we subtract the 50 from 180, that means that this arc, which is the arc of B degrees, would be 130, because the 150 degree and now the 130 adds up to 180 going all the way around. So B would be half as much, 65 degrees. All right, so you're gonna have to be patient with me because the rest of them I'm going to have to draw as I go along. It's gonna take a moment, but not too long, I promise, not too long. All right, so our next one up would be 17. Number 17 is asking about an angle that is formed by two tangents. Tangent 1, tangent 2. Sorry, I'm using big dots to make sure you can see that they are tangent points. And we're looking for x. 120 is given. Well, usually for this, the angle is equal to the big arc minus the small arc divided by 2. Well, the angle is x, or x degrees, and we're looking for that, but we're missing this big arc. We have this small arc of 120. Well, knowing that a circle is 360 degrees, 360 minus 120, we get 240. So now we do know the big arc because the whole circle is inside of those two tangents. So now 240 minus 120 divided by 2. This gives us 120 divided by 2 gives us 60 degrees, which is the answer for our angle. All right, next one up. This one, very similar to this one, is going to use that big arc minus small arc. So this is number 18. The last one was number 17. This one's got our tangent off to the side. And it also has, as I said, a big arc, small arc situation. This time, the big arc, small arc situation, the angle is outside, but we have a secant and a tangent instead of two tangents. So it looks a little bit different. And we're looking for the arc. We're given this angle is 40 degrees. Sorry about my sloppy drawing there. This arc is 140, and we're also going to look for angle Y when we're finished finding arc X. Okay, because we need to find X before we get to Y. So now we've got, again, angle equals big arc minus small arc divided by 2. How do we know when to use this? Well, we know when to use this when the angle, its vertex, is outside of the circle. That's when we know to use this formula. If it was inside, we'd be adding the arcs and dividing by 2. Or if it was on here, we'd be looking for the arc and just taking that single arc and dividing by 2. So angle, 40 degrees. Big arc, 140. Small arc is X. Divide by 2. To get rid of the 2, we multiply both sides by 2. We get 80 equals 140 minus X. And then X is going to be 140 minus 80, or 60 degrees. Now we need that 60 degrees because we've got 140 and 60, this part of the circle, that's 200 degrees. The full circle is 360 degrees. So that means what's left over for this arc, 160. And this angle is half as much, 80. All right, so I hope that was helpful. So we had our 60-degree arc and our 80-degree angle for 18. All right, let's see what's the next number up that I've got, number 21. So now a very similar picture to what we just had, but now we're solving for segments. And it's a matter of knowing the pattern to follow or the formula to follow. So take good notes. Okay. Number 21. In number 21, we've got the external secant segments. That's just these outside parts. And then we have this whole secant segment and this whole secant segment. So the outside parts, 11 and 12, are outside of parentheses. There's an equal sign here. What goes inside the parentheses? 11 plus 22. And here, 12 plus C. So the pattern is, and this was 11 plus 22 in there. I just simplified it to 33. Outside parts, pull everything on that secant inside. Everything on that secant added up inside. Now we can just solve. And I won't pretend to know that when I know 11 times 33. That is 363 equals 144 when I distribute, plus 12C. So now subtract 144 and divide by 12, and it comes up to 18.25. And rounded to the nearest tenth, 18.3. That was the instruction there, so we'll round it to the nearest tenth. All right, now this pattern will continue for the next problem that was already also asked for, that's 22. And we'll see it very similar in 23 as well. We're going to do 22 and 23. Now, this one is asking not only to find the X value, and it has a, oh, excuse me, not a tangent. Here it's going to be a secant of 47, 5, and we have a value of 8 in here, but we've got this tangent right there. Hopefully you can tell that's tangent from my drawing. So this is the 8 portion right in there. Now let's ignore the Y altogether. Just pretend like it's not there. So covering that up, pretending like it's not there, we've got a secant and a secant. So what we just did, exterior parts are 8 and 5. 8 plus X, 5 plus 47, and 5 plus 47 we know will give us 52 here. So now we'll do 5 times 64 here, 8 times 8 plus 8x equals 5 times 52, 260, and we'll subtract 64 and divide by 8. So I get 24.5 for x. And that was actually an exact answer. Since it said round to the nearest tenth, that one did not need to be rounded, luckily, so it's exactly what it needs to be. Now, putting that in, let's pretend like this doesn't exist. We don't need any of that. When you have a pattern with a tangent and a secant, pattern's a little bit different. When you have the tangent, all you have to do is square it on a side all by itself. Tangent squared. For the secant, we follow the pattern that we've been doing, 8, and then 8 plus whatever the rest of the secant is. So 8 plus 24.5 now. Now that it's not an x anymore. So we can add 32.5 in here. Okay. All right, and then we can say 8 times 32.5, which is 260, and this time we are going to do some rounding. We're going to do the square root of 260, and we get 16.1, and that is rounded to the nearest 10, just making sure that the instruction is followed. Okay. So we followed our old pattern with the secants, and now we used our new pattern, tangent squared on one side, the external secant part outside, and the whole inside and outside parts added together. Okay, we get to do this pattern one more time for 23. All right, it's asking us for the diameter. And that's perfectly fine because it just so happens that the diameter is the inside part of that secant. The outside part is 17 here, and this tangent is got a tangent part of 25. So as we did before, and yes, again, this is 23, 25 is squared. 17 is the exterior part, so it's outside the parentheses, and 17 plus that diameter, because this is our diameter right here. When we find D, we've got our diameter. So let's get solving. This is 625. I think 17 squared is 289. Yes, 289 plus 17D. So 625 minus 289, and then divided by 17 gives us 19.8 for that diameter. And that again is rounded to the nearest tenth. Okay. Moving on to the next page. 24. Now this one can get a little tricky because it's not as straightforward as it seems. (24) All right, we've got a diameter running through the middle. When we have a diameter running through a chord, it's automatically perpendicular to it. That was already given. If it's perpendicular, it means it's bisected. So the other information that was given is 3 and 13, and they ask you for the diameter. Well, first thing, we get to go back to something previously in the chapter. And previously in the chapter, it says, again, if there's a perpendicular, this is bisected. The bisected was not given in the picture, so you get to write, hey, that's bisected, that's 13. Second thing that we saw previously is if this is a right angle, we are allowed to write oh, excuse me. I was going to say we're going to do Pythagorean theorem, but we're not. We are going to find x right here. Now, why am I using x and not d? Well, because our diameter is not just x. Our diameter is x all the way across plus 3. So we have to remember to add that 3 to it. And I've seen a lot of students in the past week solving this problem and forgetting to add that little extra piece onto that segment to make it the diameter. So now we've got one chord crossing another, and we just do 13 times 13. That's the pattern. Multiply the two numbers on this chord times the two numbers on this chord. Well, that's not too complicated. We get 169 equals 3x. And we get 56.3 for x, and we have to add the 3 to it. So, excuse me, that squiggle didn't turn out very well. 56.3 plus that extra 3, 59.3 for our final answer. And that was number 24. So I think the person who requested that actually had the 56.3. They just forgot to add the 3. So if this is a quiz, that would be a partial credit situation I could give students back. So I haven't evaluated those for partial credit yet. It takes me a couple days, as you know, so I will work on that. Now, next one up is very similar, and this one is going to use the Pythagorean theorem. I was already thinking about that in number 24, but we're actually going to use Pythagorean theorem here and some previous knowledge. So in this one, diameter, chord, and they give you this, a bisected arc. Well, if the arc is bisected, that means the chord is also bisected. And if it's bisected, that means it's a right angle. It's perpendicular to that diameter. So they give you an x here, which does go from this point to that point. That's your x that we're solving for. But we have a 5 here. That 5 can also be transferred here. And the remaining thing that they give you is a 15. So you would have to recognize that this is 5 and that this is a right angle. So we can solve for x using the Pythagorean theorem. Why we're not using the 5 times 5 and the multiple is because this section of the chord, this segment y, is missing. So we can't do 5 times 5 y times x because we have two variables. So we're going to go to this right triangle in here and say x squared plus 5 squared is equal to 15 squared. So x squared plus 25 equals 225. And when we subtracted, x squared is 200. And we're going to go ahead and just say square root of 200 right now. Now, what is the square root of 200? For the purposes of x, and it says round to the nearest, it's somewhere under 15. So the square root of 200 is 14.1. Now, for the purposes of plugging it in, you can either use the square root of 200 or 14.1. Those should work just fine. But now we're going to find the x value. And this is y times that square root of 200. You can also plug in 14.1 instead of that. These two multiply together, and 5 times 5 multiply together. So 25 divided by the square root of 200, or 14.1, will come out to 1.8. And yes, that's very proportional. A lot of times the pictures aren't to scale, especially if I'm hand drawing them on the board as quickly as I can. But most of the time they won't be deceptive, so you don't have to worry about that. Okay. All right. let's see what we've got next. Okay, the next part, my favorite, equations of circles. Let me make sure I did not skip anything. Nope, I did not. I did that one. I did that one. Perfect. This one was 25. Just double checking. Wonderful. So now we're on 30, 31, and 32. These are all about equations of a circle. And with the equation of a circle, there are two things that are important, the center and the radius. So keep in mind your equation, x minus h squared plus y minus k squared equals radius squared. A couple of things that I've seen already, and the person who requested this actually put an x here and an x here in their answer, so that's just a typo. But I'm going to run through this several times. Let's say number 30 said, okay, I've got a center -3, 4, and a radius of 8. As opposed to number 31 that said I have a center 0, 0, and a radius of 9. Well, in both cases, we're just going to plug these in. Notice this says negative, so whatever signs they are, it's going to be the reverse. So if we plug in -3, that's going to turn to positive or +3. And then y minus 4. So now that's positive, and this is negative. R is going to be squared. One of the biggest mistakes students make is accidentally multiplying 8 by 2 instead of 8 times 8. So watch out and make sure you don't make careless errors, because I don't want those to cost you points. Now, that was 30. Now, 31. Well, if I'm plugging in 0 here and 0 here, what happens? Well, I get x squared plus y squared. The 0 disappears. X minus 0 is x, y minus 0 is y. So I get x plus y. My radius of 9 gets squared again. So the person who requested this just forgot to type in the x squared plus y squared. They put in the radius squared, but they forgot that it's not x times 0, it's x minus 0. So you do have x squared and y squared there, which just means that is at the origin when you graph it. Okay, now what if, same equation, number 32 says, I'm going to give you a center point and a point on the circle. So the center point is -1, 6, and a point on the circle, so that's the center. Another point just on the circle is -1, 10. Just for visualizing purposes, that means that this one's at C, and we'll just call this point point G. So to find the distance from C to G, that's our radius. So we already have the center point. We already know plugging this in, we're going to have x plus 1 squared plus y minus 6 squared. But we're still looking for our radius squared. We don't know our radius this time. Our radius is missing. So our radius, we have to use distance formula on these 2 points. So the radius is equal to the square root. -1 and -1 subtracted. Well, if you're subtracting the same number from itself, it's going to be 0. So that's going to cancel out. Plus 6 minus 10 squared. And some of you might say, is it supposed to be 10 minus 6? Does the order matter when you plug that in? It does not. So 6 minus 10 is -4 squared is 16. And well, the square root of 16 is a perfect square. So the radius is 4. So that means if we're doing plugging in 4 squared, what number belongs there? 4 squared is 16. Okay? All right. And yeah, that's no coincidence that that 16 is the number. Okay? Okay, so this is your equation given a center point, like C, and a point on the circle that I just called G. Again, use your distance formula. It may have been a little while for some of you guys to use the distance formula. We haven't used it since January, February on our exam a couple of times for third quarter. All right, let's do another one, graphing. And then we'll be all pretty much wrapped up, just about. Graphing and a slightly more complicated equation. So now, if we know our center and we know our radius, make sure that you familiarize yourself with the graphing tool, okay, where you pick the center and then you are going to bring your circle up until it fits in the graph. Occasionally, it doesn't, if you mean it to draw it out a little to a certain point and click it in place, it doesn't click exactly in the right spot, but when I grade it, I'll catch it. All right. So let's do 33. It has a coordinate plane, and it says, okay, I have got this equation of a circle, x plus 5 squared plus y minus 3 squared equals 16. So this is your center point, but it's not positive 5, it's negative 5. It's not negative 3, it's positive 3. So your center, let me go ahead and move this a little bit higher. Your center is going to be at 1, 2, 3, 4, 5, and positive 3. Actually, I don't know why I moved that up, because I am going to need something more like this. 1, 2, 3, 4, 5, and 1, 2, 3. Obviously not perfect because I'm hand drawing it. Now, your radius squared is this number. Not the radius, but the radius squared. So the square root of 16 is 4. So what do? You go 4 in this direction, 4 this direction, which would be a little bit below. Sorry about that mess right there. Here's 4. Here's 1, 2, 3, 4 about this direction. 1, 2, 3, 4 about here. 1, 2, 3, 4 about here. Now you can tell a MATLAB a point, or you can just pull that tool until you get that circle. Okay. All right. That was 33. So number 34, and then number 35. Maybe I can put these, no, I can't put these both on the same graph, but that's okay. We're getting close to wrapping it up. 34, we've got x squared plus y squared equals 36. So this means that your center is 0, 0. If it says x squared, y squared, the reason why there's no h and k value is because it's 0. And then the radius squared is 36, so the radius is 6. So we just go to 0, 0, and we go 6 up, down, side, and side, and draw the circle, or pull the circle outward. Okay. For our last one of drawing the circle, and then we'll get to a couple more sorted problems really quickly, one a little bit harder. 35. X minus 5 squared plus y minus 3 squared equals 16. So this means our center is 5, not negative 5, positive 5, not negative 3, positive 3. 5, 3 is our center. And the radius squared is 16. That came up again. So we go 2, 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, put our center point. And then we go 4, 1, 2, 3, 4 up, 1, 2, 3, 4 down, 4 over. So I'm just using dots here to get it somewhat accurate and close enough for a hand-drawn graph, right? Okay. So that was 35. Now, the last two questions that I was given were just a little bit harder. Number 36, I would consider the hardest one with the equation of a circle, because you have to use two formulas, midpoint and distance. Yay. So I did not draw this on a coordinate plane. I just drew a sample circle. A is 3, 4, and B is 7, 6. When we're building the equation of a circle, we need two things. We need the center and we need the radius. We don't have either. However, we can find the center, we'll call that C, if we use the midpoint formula. So for those of you who don't remember, I'm sure you all remember, right? 3 plus 7 to find the midpoint. You're adding the x's and dividing by 2. You're adding the y's and dividing by 2. So this is 10 and that's 10, so the center is 5, 5. 10 divided by 2 is 5, so 5, 5. Now that we have the center, we need to get our radius, r. Now we've got to use this center, 5, 5 to do it. I'm going to go ahead and use 5, 5 and 7, 6 to get my radius and use the distance formula. 5 minus 7, or 7 minus 5. Let's go ahead and put the bigger one first, no negatives. And 6 minus 5. And make sure you're subtracting inside the parentheses, adding in the middle, squaring. Okay, so 2 squared is 4, 1 squared is 1. So we get the square root of 5 for our radius. You're like, oh, square root of 5. Well, that's okay, because if this is our center, we've got x minus 5 squared plus y minus 5 squared, because remember, those are the opposite sign. And the radius gets squared. So what is the square root of 5 squared but 5? So when we square it, we just get 5, because the square root squared is the number that's underneath the radical. Okay, so that one took the longest because we had to do midpoint, we had to do distance, and then we had to plug it in. Last one, which is going to be a lot shorter, which is number 37. Number 37 says, okay, I've got x squared, x minus 2 squared plus y minus 3 squared equals 25, and I want to know the circumference of the circle. Well, I'm also going to throw in, just for lagniappe, the area of the circle, and it says type an exact answer in terms of pi. Well, circumference is 2 pi r, and area is pi r squared. This is the one I asked for in the problem, but I'm just throwing in area because you never know on the test whether it's going to be a circumference problem or it's going to be an area problem. But no matter what, you're going to need the radius. So where do we find the radius? Here. The radius squared is equal to 25. So the radius is 5. So for our circumference question, 2 times pi times 5 gives us 10 pi, and of course they provided the word units behind it. So this would be our answer for circumference. That was the answer to the original problem. Now, if we're asked for area instead of circumference, we would plug in 5 squared, and we get 25 pi units squared. And that would be the answer. So I made sure to put both because these two formulas are often actually mistakenly interchanged, and people will put 25 pi when they mean 10 pi or 10 pi when they mean 25 pi. So always reread the question and make sure you're using the correct one. Don't rush. It's not worth it. Okay, so I hope that these were helpful to you. If you missed any other problems on your quiz, please feel free to email me. I will try to shoot back a picture of that individual question, but there were so many, it was worth doing a YouTube video. Bye for now. Good luck on your quiz and your test.